Hello friends, myself Salil Gadge. I am a mathematics teacher. In this video, I am going to explain why SSA, that is side-side angle, is not a valid test for congruency of triangles. Let's see why. So let us understand the meaning of congruency. You would notice that on this board I have drawn 6 triangles here, and what we want to do now is we want to use this particular set square and we want to find those triangles which exactly match this set square. So I'll try placing this set square on triangle 1 and you will notice that this triangle does not match with the triangle 1 shown on the board. The triangle, the set square, does match triangle number 2, and since the two triangles exactly overlap each other, I would say that the set square and triangle number 2 are congruent to each other. So congruency basically means overlapping figures. Similarly, if I take triangle 4 and I place the set square on that particular triangle, you would notice that these two triangles exactly overlap over each other, and therefore I can say that this set square is congruent with triangle 2 as well as triangle 4, and therefore triangle 2 and triangle 4 are also congruent to each other. Therefore, if I took this triangle 4 and I rotated it somehow, it would definitely match triangle number 2. Similarly, you would notice that this set square does match triangle number 6. Therefore, triangle 2, triangle 4 and triangle 6 are definitely congruent to each other. If I now take the next set square, you will notice that this set square exactly overlaps with triangle 1, it exactly overlaps with triangle 3, and it exactly overlaps with triangle 5, and therefore triangle 1, 3 and 5 on rotation, they can be overlapped with each other, and therefore triangle 1, 3 and 5 are congruent to each other. Therefore, congruency in principle means overlapping figures.
Good.
So now what we are trying to understand is whether SSA, that is side-side angle, is a test for congruency in triangles. For this, let us construct a triangle ABC with dimensions AB equal to 10 centimeters, BC equal to 6 centimeters and angle A equal to 30 degrees. So take out your geometry boxes, take out a piece of paper and do this construction with me. So what I'm going to now do is, I'm going to construct this triangle at two different places, and then we'll see how it goes. So first I'm going to construct AB equal to 10 centimeters. So I take this measurement and this is, I take this measurement and this measurement is 10 centimeters or 10 units. Similarly, I construct a 10 centimeter or a 10 unit base over here as well. Let's mark these points as A and B as shown in the diagram here, and let's mark this measurement as 10 centimeter each. Now we need to draw a 30-degree angle. Right now I'm going to draw this angle using a protractor. Later on in the next videos I'll show you how to construct a 30-degree angle with a rounder. So let's place this protractor at the vertex and let me mark a 30-degree angle. Similarly, I'll place this at vertex X, vertex A, and I'll again mark a 30-degree angle. So now using a scale, join A with this particular point. So now we have got angle A as 30 degree in this left triangle, and similarly join A with this particular point. Have you constructed it this far? Okay, so now what we need to do is we need to take a 6 centimeter measurement from vertex B. So I have a rounder over here and I have already taken the measurement as 6 centimeters. You can take the same measurement on your geometry instruments. Place your rounder at B. So I am placing it at B here, and you will notice that you can actually mark an arc intersecting the ray A, the ray passing through A, the 30-degree ray through A. You can actually intersect it at 2 different points. Correct? So you place your rounder at B and you will be able to intersect this 30-degree ray at 2 different points. Repeat the same procedure from this point as well. So I have placed my rounder at point B and I am drawing a 30-degree arc. So you will notice that you can actually get these 2 arcs after placing your rounder at B. Okay, so after getting these 2 measurements, now what I am going to do is, now this is something that's very interesting. The point of confusion is which point do I join with B. So even if I take this point as C and I take this point as C dash, you will notice that even if I join C with B over here, whereas over here if I choose to select this particular point and join with B, the measurements of BC are still 6 centimeters in both cases. So BC is 6 centimeter here, as well as in this case also BC is 6 centimeters. So now you will notice that the 2 angles are equal in both triangles, 30 degree, 30 degree. The base is also equal, which is 10 centimeters. The length of BC is also 6 centimeters in both the triangles, but you will notice that these 2 triangles absolutely don't overlap over each other. And the reason for that is there are 2 points on this 30-degree ray which can actually get you BC equal to 6 centimeters. So the point of confusion is if I join B and C dash, this is also 6 centimeters. Whereas let's assume that this particular point is say X. If I join this measurement is also 6 centimeters. Now over here you will notice that you have triangle ABC and triangle ABC dash. These are the 2 triangles with absolutely the same measurements that have been shown over here. Whereas here you have triangle ABC. Okay, just for convenience let's mark this point as X dash. So we have ABX dash and we have triangle ABX here. You will notice that the triangle ABC on the left hand side exactly is congruent to triangle ABX. So ABC is actually congruent to ABX, whereas triangle ABC dash is absolutely congruent with triangle ABX dash. But the important point to note here is ABC is not congruent with ABX dash, and because there is no clarity over here whether the point C lies at this point or whether at this point, because of this lack of clarity you are not sure whether ASS is going to guarantee congruence or not. Because of this lack of clarity, ASS or SSA, side-side angle, is not counted as a test for congruency. I hope this construction really cleared out the concept why SSA, side-side angle, is not a test for congruency, because you can construct exact 2 triangles, 2 different triangles with the same measurement that is given over here. I hope this clears it up. I do hope you found this video interesting and it cleared a few concepts in geometry. In the next video, I'll come up with something new, some new idea, some new concept. Do like, share and subscribe my YouTube channel and stay connected. Goodbye.